Section 13.1.13. The data in the accompanying table represent the number of corn plants in randomly sampled rows, a 17-foot by 5-inch strip for various types of plots. An agricultural researcher wants to know whether the mean numbers of plants for each plot are equal. Okay, so the first plot is the sludge plot, and there are our values. The next column is the spring disc, and there are our values. And then the last column is no-till, which is the last column here. So the first part is we want to be able to write the null in the alternative hypothesis. So since this is an analysis of variance talking about 3 different various types of plots, the null is going to equal the mean of the sludge, which is equal to the mean of the spring, which is equal to the mean of the no-till. And then the alternative is that at least one of the means is different. Okay. Next, for part B, it says state the requirements that must be satisfied to use the one-way ANOVA procedure. Well, the requirements of a one-way ANOVA test are given below. First, there must be k simple random samples, one from each of k populations. The k samples must be independent of each other. The populations must be normally distributed. And the populations must have the same variance. In part C, it says use the following one-way ANOVA table to test the hypothesis of equal means at the alpha equals 0.05 level of significance. So here is the one-way ANOVA with the sludge plot, spring disc, and no-till. Here's the source, df degrees of freedom, the sum of the squares. This is the mean of the squares, the f test statistic, and the p-value. We have the factor, which is the first row. We have the error, which is the second row. And then we have the total, which is the third row. So the first thing we need to do is we want to find the test statistic for this data, rounding it to 3 decimal places. So if we take a look over here, f, there is our test statistic. So therefore, f is going to equal 8.82. Okay, and then we want to find the p-value rounded to 4 decimal places, which is just only rounded to 3 decimal places. So the p-value here is 0.003. Okay, now in step 3, we want to compare the p-value to the significance level. Well, the significance level is given to be alpha, which is 0.05. So if alpha is 0.05 and we know the p-value is 0.003, we can see that the p-value is less than the significance level. Now, if the p-value is less than the alpha level of significance, we reject the null. Otherwise, we do not reject the null. When the null hypothesis is rejected, there is sufficient evidence to support the alternative hypothesis. When the hypothesis is not rejected, there is not sufficient evidence to support the alternative hypothesis. In this case, since the p-value is less than the significance level, we're going to reject the null. Therefore, there is sufficient evidence to support the alternative hypothesis. Thus, there is sufficient evidence to conclude that the mean numbers of plants for each plot type are not equal. Okay, shown over here are side-by-side box plots of each type of plot. So do these box plots support the results obtained in part C? Well, a box plot might suggest that the means of any 2 samples are significantly different if the boxes do not overlap. Now, if you notice that the sludge box plot does not overlap with the spring disc box. Therefore, these box plots support the results obtained in part C because the box plots show that at least one of the means is significantly different. Okay, and then the last thing is we want to verify that the residuals are normally distributed. Okay, so in order to do that, we can take a look at StatCrunch. So if we come up over here and we're going to open up this data into StatCrunch. Okay, so what we're going to do is we want to find the Q plot of the residuals. So in order to do that, what we're going to do is we're going to go to Stat, and then we're going to go to Anova, and then select one way. And then what we're going to do is we're going to go ahead and select all three of these so that we can get this graph over here. And then what we're going to do is we're going to get the Q plot of residuals with the correlation. So if we select compute and then look over here, we're going to get that graph that we have on the left. And so therefore, we would then say that the normal probability plot and linear correlation coefficient R of 0.975 will tell us that the residuals are normally distributed.